Okay, so that Anna can get her picture, I'm just going to write that linear speed velocity is going to be equal to s divided by t. Well, we're going to do a short application today using our radians, and then we're going to move into more of the heart of trigonometry. So the second part of today is going to be really essential for your test, as well as for your final exam. This is just a short little side note that we didn't get to yesterday. I was trying to give you time to kind of work through that worksheet. So that's a little bit longer instruction today and things we had to practice in e-learning, and thank goodness for e-learning. So yeah, we're very good, very good. Yep. All right, here we go. So I have angular speed. Angular speed is theta divided by t, and we use the letter omega. Omega is the Greek letter for the long O sound. Maybe you're more familiar with omega looking like this. That'll be the capital omega. In ancient Greek, they did not have capital letters. This was not introduced till much later, but all Greek was just smaller case letters. Actually, no punctuation or spaces between words either. It was just all written straight across. So it's challenging. So anyway, so look at what we have here. It says a bicycle wheel. It's 24 inches diameter, and it rotates 100 RPM. RPM means rotations per minute. Okay. So, for example, your a disk drive maybe rotates at 3,000 rotations per minute. My router that I use for woodworking at home rotates at, say, 30,000 rotations per minute. Okay. This one's 100 rotations per minute. So we're going to calculate omega, and that's equal to theta divided by time. And so calculating theta is really the new part that people struggle with. Theta is the angle that's being turned. So a full rotation is how much in radians? 2 pi. Good job. So I have 2 pi is one rotation. How many rotations do I have in this situation? 100 of them. Omega, it stands for angular speed. We're looking for angular speed. Divided by, I'm going to convert this to seconds. How many seconds passes by when it rotates 100 times? 60. And so therefore, I have a very quick calculation for angular speed. And I go 2 pi times 100 divided by 60, and lo and behold, I get 10.47. And we are measuring, the angle is being measured in radians per second. Now, let's get a reference for that, okay? 10.47 radians. Is that more than once around or less than once around? It's more than once around, isn't it? Because 2 pi would be 6.28. Yeah, so it's rotating more than 6.28 in a second. You see that? I think to develop a context for understanding what's happening, I think it's good. Okay. Now, let's move on to the next piece. It wants us to find the linear speed. So that if that bicycle wheel is turning, we would really probably be wondering how fast is the bicycle going, right? In order to do that, we take velocity is equal to s, which refers to distance divided by time. Okay? Now, since we're talking about a wheel, s, as we talk about distance, can also be thought of as arc length. Did we talk about arc length yesterday? And I'm going to use that to come up with a new formula and a much better formula. Are you ready for an easier way? Let's do the easier way. Thank you for your emphatic response, Eve. Omega is equal to theta divided by t, we said, and velocity is equal to s divided by t. Well, what is s in terms of what we talked about yesterday? Very good. R theta. We said in order to calculate arc length, you took s and you took r and multiplied by theta. Remember that yesterday? Awesome. Now I'm going to slightly rewrite this. Velocity is equal to r times theta over t. Are you okay with that? I just use the commutative property of multiplication. Now, what is theta over t? Omega. Thank you. So velocity is equal to r omega. So instead of using this formula, s over t, we can use r omega, which is really, really helpful when we're working with circles. Sorry, YouTube Nation. Right now they're asking about our use for Greek letters as opposed to English letters. So at what point do I tell them how superior the Greeks were to us? I mean, it's an honor to be able to use the Greek alphabet. I mean, it really is. So. I feel like you guys should develop your own branch of mathematics and present it next week. Sure. Shh. Let us find linear speed. We move on. Linear speed, we take velocity is equal to r omega. So, do we know what r is? 12 times, do we know what omega is? 10.47. Ooh, hey, I'm going to multiply that. If it did, you would just leave it in terms of pi as opposed to multiply it together. Okay, so Lisbeth has it. For tomorrow, you won't use your calculator. Okay, so on the actual test and the rest of your user calculator, just converting degrees to radians. I think you should. I think it's very fair to expect that we can handle that without our calculator. Okay. 125.66, and that's radians. Well, I'm sorry. This is velocity. What's our distance measured in? Per. Very good. So let's try one more example, a little bit shorter than that now that we kind of see the basis. We have a paddle wheel. So we've got 0.3. The water is moving by, the paddle wheel is spinning, okay? And the question is, what is the speed of the current? So I want to know velocity, and velocity is equal to r omega. Do we know what r is? 0.3 times, oh no, if I only knew what omega was. Can I figure out omega? Omega is equal to theta divided by t. What is theta? One rotation is how much? 2 pi. How many rotations do I have? 80. And I divide by? It says it wants it in meters per second. So 60 because there's 60 seconds in a minute. 2 pi times 80 divided by 60. And I get 8.38. That's what omega is. I multiply it by 0.3. And I get velocity is equal to 2.51 what? Meters per second. You guys are extremely intelligent. Way to go. I wanted to do that yesterday, but I need to give you guys some more time to do stuff. So I just want you to do 2 problems on that. We have more to do today, but this is just what I want you to do for that. Okay. 6.1, page 482, number 65 and 69er. And now we get to the heart of our lesson for the day. You don't need that. Don't worry about it. Nope. If you don't need that. Are we filled that out, didn't we? Yeah. So we said velocity is equal to r omega. Oh, okay. All right, flip it over, and here we are. Today is an extremely important day. We define our trigonometric functions. You're going to hear me make some absolute statements, and I do mean them when I say them, okay? So the question is, if we have a circle with an angle measurement of theta and a terminal point of x and y and a radius of r, most time will be in the unit circle, but we'll just put r in case we're not. Question is, how do we define sine? So SOHCAHTOA comes to mind. Again, I told you I never learned SOHCAHTOA. I'm not going to start by teaching you SOHCAHTOA right now. We'll do it on Monday, okay? But for today, right now, as you look at this, we're going to define sine. Now, you're going to be kind of tempted to say, well, why is sine that, Mr. Gins? That's what we're defining it to be. It's kind of like, why is an apple an apple? Well, somebody decided the red things that grow on trees, it tastes really good and are good in pie. We're going to call those apples. Okay? So, same thing here. Sine is defined as the y value divided by the r value. Now, this will help you remember. Okay, the good sine story, I just told it. We have sine, that's y over r. In the unit circle, what is r? 1. So therefore, sine is just the y value in the unit circle. And that's a lot of fun. This is cosine. And cosine is identified as x over r. Or in the unit circle, it would just be x if you were in the unit circle. Tangent is y divided by x. This is cosecant. Cosecant is the reciprocal of sine. It is 1 over sine of theta. If I take the reciprocal of y over r, what do you get? R over y, or in the unit circle, 1 over y. This is secant, which is 1 over cosine. It's the reciprocal of cosine, which would be r over x, or as William said, 1 over x in the unit circle. And cotangent is 1 over tangent, or x over y. Yes, updated, thank you. Now, you're going to be tempted. Okay, here we go. We are going to now take care of a few of these. I'm just going to change some of these pieces. So what we're going to do today is we're going to identify exact values of trigonometric functions for given angle values, okay? So we want to know the sine of pi over 3. And in fact, we're also going to show the cosine of pi over 3. And we're also going to show the tangent of pi over 3. We're going to do all 6 of them for the others. Okay. So this has an exact value, sine of pi over 3. And I'm going to calculate it, and I'm going to calculate it by drawing a circle. Pi over 3 is how many degrees? 60? Yep, so that's something you need to know. We won't pause in class to try to convert pi over 3 to 60 degrees. That's something we need to come to terms with, which is why you have your quiz tomorrow. So I have 60 degrees. This is 1. The radius is 1. What is the length of the shorter side? 1/2. So the length of the longer side, root of 3 over 2. So therefore, the terminal point is what? Awesome. So the cosine would be what? I'm sorry, the sine would be what? The x or y value? Y value. So the sine of pi over 3 is the root of 3 over 2. Now, look at my calculator. This is kind of cool. If I hit mode, you see I'm working in radians. And if I hit the sine of pi divided by 3, I get that, which is the root of 3 divided by 2. Your calculator comes up with that exact value. If you write 0.866 on the test, I give you 0 points. The exact value is square root of 3 over 2. Every year it happens to me. So chances are out of the 58 students currently taking this class, that one person is going to write 0.866. I give you 0 points. You write the square root of 3 over 2. Okay, that's what you need to have. All right, I do the cosine. Cosine is which value? The x value. So it is 1/2. How do I calculate the tangent value? I take y over x. So square root of 3 over 2 divided by 1/2. How do I divide? Multiply by multiply by 2 over 1, and you get root of 3. Now, if I go to my calculator and I do, watch this, I do tangent of 60 degrees, I do not get the root of 3. The root of 3 is 1.73. You know why I didn't get the root of 3? Because I'm working in radians. If you tell your calculator, I want to work in degrees. Well, now if you take the tangent of 60, you get 1.73, which is the square root of 3. So you need to tell your calculator whether you're working in radians or degrees, and that's something we're going to have to be careful of over the course of this entire rest of our year. Okay, so we'll talk about it. It's in mode. Definitely want to get familiar with that calculator and that operation, and we will. Trust me. Okay, the next one, theta equals 3 pi over 4. I'm going to come up with an angle here. As I come up with the angle, I'm going to list sine of theta, cosine of theta, tangent of theta. And then I'm going to do cosecant of theta, secant of theta, and cotangent of theta. I'm going to do all 6 trigonometric functions for theta equals 3 pi over 4. Somebody please tell me how many degrees is 3 pi over 4? 135. Everybody good? 135 degrees. So what special right triangle is formed? 45, 45, 90. We've done this before, right? That's why we did that. So we can do this. So what's the length of the radius? 1. What is the length of the other side? How did you get that? Now, you might say to yourself, why is that important? You're going to see as we work here why that's important. So what's my terminal point? So what's the sine value? Root of 2 over 2. What is the cosine value? Negative root of 2 over 2. What is the tangent value? Negative 1. Does that make sense? If you divide those, you get negative 1. Now, watch carefully. Sine, cosecant will be the reciprocal of that, right? So 2 over the root of 2. It's just easier to look right here. Instead of taking the reciprocal of root of 2 over 2, let's take the reciprocal of 1 over the root of 2. What's the reciprocal of 1 over the root of 2? It's root of 2. Which, if you simplified it, that's what you would get. So what is the reciprocal of negative root of 2 over 2? Negative root of 2. And what's the reciprocal of negative 1? Negative 1. Think you have negative 1 is negative 1 over 1. If you take the reciprocal of that, you still get negative 1. So reciprocal does not change sign. It just flips it. Okay, those are my 6 trig values for that given function. Not extremely challenging, but definitely new, right? Actually, I think that your geometry teachers have started to incorporate a little of this into their geometry instruction. Good. It's made a difference, though. It helps to now see it a second time instead of a first time. I've noticed a difference as I've talked. People catch on a little bit more quickly. Negative 3 pi over 2. I'll do sine of theta, cosine of theta, tangent of theta. I'll do cosecant of theta, secant of theta, and cotangent of theta. William, be our leader. What is the angle measurement? Which places me at negative 270 will place you at 90 degrees or 0, 1. You all good? Exact situation just about that I was using in calculus today. We use these all the time. We need to be good at them. I don't need to draw a triangle, do I? What sign? That'll be 1 over 0, which is undefined. Tangent is undefined at 90 degrees. Cosecant is the reciprocal of sine, which is... What's the reciprocal of 0? Undefined is the reciprocal of 0. What is the reciprocal of undefined? 0. You like that, don't you? There you go. I have a nice worksheet for you.